Here we'll first understand the definition of a polynomial and then look at a few examples of functions and check if the functions are polynomials or not. So f of x is an, x to the an minus 1, x to the n minus 1 plus, and it keeps going, plus a2x squared plus a1x plus a naught. Now, a polynomial looks like this as long as the coefficients of the x terms are all real numbers. And here are examples of real numbers. Radical 2 is real. A decimal number is a real number. If you have a radical expression in a number, that's real as well. E is a real number, pi is a real number, 7 obviously is a real number, a fraction is a real number, whether it's positive or negative. A recurring decimal is also a real number. A non-recurring decimal is also a real number. Anything other than a negative inside the radical sign, now that would be imaginary. Okay, so as long as the coefficients, when I say coefficients, it's these numbers that are multiplied to the x terms. The coefficient of the x terms have to be real. Now the second condition, so that's our first condition. The second condition is that the exponents on the x terms are non-negative integers. So what are examples of non-negative integers? They are whole numbers. 0 is included. And how does 0 figure in this? If we have a naught, we could write it as a naught times x to the 0. So starting with 0, we go to 1, 2, 3. Anything that doesn't have a negative sign in front of it, a whole number, is a non-negative integer. So let's look at a few examples and determine whether these functions are polynomials or not. Let's look at the first one. So f of x is given by this expression. So let's look at the coefficients of the x terms. That's including the negative sign. They're all real numbers. So the first condition is satisfied. The second condition, so the first condition is that all the coefficients of the x terms are real numbers. The only time a number is not real is when you see an I in it or a square root of a negative number. The second condition is that the exponents on the x terms must all be non-negative whole numbers, and that works as well. So therefore, the first example is a polynomial. The second function is 7.25 x to the 100 minus 25 x to the 4th minus 1. So this is the second function. So let's look for the x terms and look at the coefficients of the x terms. Coefficients of the x terms are the numbers multiplied to the x terms. We have 7.25, we have negative 25, we have negative 1. All real. So the first condition is satisfied. Now the second condition says that n, the exponent, has to be non-negative. So that's pretty clear here. That's a non-negative whole number or a non-negative integer. That's a non-negative integer. So therefore, the second condition is satisfied, and this is a polynomial as well. Now let's look at the third example. F of x equals 5x to the negative 5th plus x plus 1. Is this a polynomial or not? So look at the coefficients of the x terms. So that's a 1. If you see nothing, that's a 1 multiplied to x, and then of course another 1. So in each of these numbers, it's pretty clear they are real numbers. But now let's check for the second condition, where all the exponents on the x have to be non-negative. So that's a problem, right? So therefore, the second condition is not satisfied. The exponent on x is a negative number. So therefore, it is not a polynomial. Now let's look at the fourth example. We have f of x equals 5 over x squared plus 3x minus radical 2. Now when we look at it, we're almost tempted to say yes, because we see a 5, a positive 3, a negative radical 2. So the first condition is satisfied. But if you look at the first term, notice that the x is sitting in the denominator, and to bring it to the standard form, we got to move it up. And 5 divided by x squared is 5 times x to the negative 2. When we move a number x to the n from the denominator to the numerator, we have to change the sign of the exponent. That's one of the rules of the exponents. So this is a problem. So basically we have 5x to the negative 2, that's what f of x is, plus 3x minus radical 2. So the second condition is not satisfied. So therefore it is not a polynomial.